So this lesson is designed to help students figure out how to determine the hybridization on an atom in a molecule, particularly in an organic molecule. We're looking at how to figure out what the hybridization is when we have a molecule, and this is kind of the background knowledge you need to know. Pi bonds come from p orbitals. Okay, they're combinations of p orbitals from two different atoms. Sigma bonds always come from hybridized orbitals. Lone pairs of electrons always come from hybrid orbitals. And we know that single bonds are always sigma bonds. Okay, they're always the first bond, if you will, one way to think about it, between two atoms is always a sigma bond. If I have a double bond has what in it? What kind of bonds in a double bond? A sigma and a pi. Okay, a triple bond, 2 sigma, or 1 sigma rather, and 2 pi. 2 different pi bonds, okay? Got that? All right, so let's look at a molecule. Here, I'll make a really big one. Okay? And let's put a couple of the bonds on there. All right. Let's look at this carbon atom right here. Right there. Okay? Are there any lone pairs on this carbon atom?
Yeah.
No, there aren't. Carbon atoms have 4 valence electrons, right? And those 4 valence electrons are going to share 4 times, or 1 for each. So, and there's 2 implied hydrogens on here.
Oh,
remember that?
I forgot about implied.
Yeah, that's right. You got to imply. That's right. You got to remember that. Okay, it's important. So, are there any lone pairs in this carbon? No, because there's 2 hydrogens we don't show on here. Okay, because that's what you do with a skeletal structural formula. You don't show the hydrogens. Okay, you only show. In fact, you don't show the carbons. Only show the bonds between carbons or other kinds of atoms. All right. What kind of valence electrons? Back it up. What kind of valence orbitals do you have in every atom? What kind of orbitals? What are the valence orbitals in any atom? Really? In the valence level of any atom, what are the sublevels or orbitals that are in there? 1s and 3p. 1s and 3p. Got that? Huh? All right. I have 4 single bonds. Single bonds are sigma bonds. Sigma bonds come from hybrid orbitals, right? There's our valence orbitals. We're going to hybridize all of them. What's the hybridization going to be? sp3 or spp. That make sense? No? I'm saying that the carbon atom had 4 valence electrons, and we bonded all of these. We share these electrons. You got 2 carbons, 1 on each side over here, and 2 hydrogens. Okay? In order to make these kind of single bonds on all 4 sides, you had to hybridize all 4 valence orbitals. We drew out orbital notation and showed how the electrons go in there and share. Okay, do that. We showed what the hybridization looks like when we combine those orbitals together using orbital notation. Okay, so if we started out with 4 orbitals in the valence level, and all the atoms, all the nonmetals have 4 valence orbitals, and we're hybridizing all 4 of them, the 1s and the 3p orbitals, we get a set of hybridized orbitals called sp3s. Okay? All right. How about this oxygen here? How many sigma bonds are there? Huh? 2 sigma bonds. Are there any pi bonds? No pi bonds. Are there any lone pairs? How many lone pairs are there? 2. Okay. Excuse me. Oxygen had 6 valence electrons. We shared 2 electrons with carbons to make this bond, this thing right here. So there's 2 lone pairs and 2 single bonds, and single bonds are sigma bonds. Well, I'm sorry, single bonds are single bonds, okay? And single bonds come from hybrid orbitals. Lone pair come from hybrid orbitals, right? How many orbitals are hybridized? Yeah, you got 2 single bonds, hybrid orbitals, 2 lone pairs, hybrid orbitals. That's 4 hybrid orbitals. So all 4 valence orbitals have to be hybridized. The hybridization is sp3, spp. Got that? All right, let's look at this carbon right here. Any lone pairs there? No lone pairs there. Okay? Huh? Why? The carbon between here and here, we're sharing a pair of electrons with an oxygen. That's a single bond. Between here and here, we're sharing 2 electrons with another carbon. Between here and here, we're sharing 4 electrons to form a double bond. Okay? The double bond comes from a p orbital and a hybridized orbital. Okay? Pi bonds. Double bonds have a sigma and a pi. Pi bonds come from p orbitals. So one of these orbitals is not hybridized. Okay? This one's not hybridized. All of the single bonds are sigma bonds. Those are hybridized. Sigma bonds are hybridized. And then we have one sigma bond and a pi bond going this way, a total of 3 sigma bonds. So we've got 3 orbitals that get hybridized to make 3 hybrid orbitals. We put all of them together, we get what hybridization? SPP or SP2. That makes sense? Yes? No? Let's look at the oxygen here. How many lone pairs on the oxygen? 2 lone pairs on the oxygen, okay? We're double bonding with that carbon. That means we've got a sigma and a pi bond going this way, right? For the pi bond, we have to leave 1 p orbital unhybridized. We have a sigma bond going this way. Sigma bonds have to be hybrid orbitals. There's 2 lone pairs. Those are hybrid orbitals. That's 3 orbitals that we have to hybridize, right? So what's the hybridization? sp2, spp or sp2. You got it? All right. How about this carbon right here? What's its hybridization? sp2. We got a pi bond in the double bond. P orbital not hybridized. spp is what we're hybridizing because we got a sigma bond here. That's hybridized orbital. We got a hybridized orbital. We've got an unseen, an unshown hydrogen bond to a hydrogen over here. That's a sigma bond. And we've got a sigma and a pi over here. That's 3 sigma bonds, and those all come from hybridized orbitals. So that's spp. Got it? What about this carbon right here? sp. We've got a triple bond here. Triple bonds contain a sigma and 2 pi's. The pi bonds come from p orbitals that are hybridized. So of our valence orbitals, the 2 p orbitals over here we're going to leave alone. Okay? For the sigma bond that is the single bond going this way, we have to hybridize one of these orbitals. For the sigma bond that's part of the triple bond, because the triple bond has a sigma and 2 pi's, we got a hybridized orbital. So we're hybridizing S and P. That hybridization is sp. Does that make sense? So that's how you can figure out the hybridization of any atom if you just think about it a little bit. Think about the process we went through to get these structures step by step and go backwards.